Hey everyone, welcome back to another exciting tutorial, and in this tutorial we are going to build ERC-2612, which is the permit extension for ERC-20 sign approvals. So if you don't know what is ERC-20, make sure you are watching my previous tutorials of ERC-20 where I explained how to deploy ERC-20 smart contract from scratch. So let's get started. So we have whiteboard over here, the diagram. So if you have previously watched my tutorials ERC-20, so you can see, let's start with ERC-20, our traditional ERC-20, the path, ERC-20 path everyone already knows. So here is the owner wallet, and to let DEX bridge or any other move their tokens, ERC-20 tokens, the owner has to send on-chain transaction, right? Which is the token dot approve and then spender and value and allowance on chain, and that arrow, you can see that arrow says the pay gas for a reason, and the owner must hold some ethereum or the native ERC-20 gas or whatever the token is. It just says yes, and no ETH, no approval, even if they have million tokens sitting idle. And after the transaction lands, allowance is set to on chain, and only then can spender call transfer form, or we have transfer form function in ERC-20, right? Then true transaction minimum for simple this let this app or like anything spend my tokens. Now let's look at EIP 2612 permit. Same owner wallet over here like ERC-20, and but instead of broadcasting transaction, they sign a message off chain, and then EIP-712. I will record this tutorial also. I will come back. So that's EIP-712 type signature for permit, and it requires no gas, then no nonce from the mempool, just cryptographic, yes. And that signature is VRS, get handed to a relay or a spender, anyone can submit it, and the person who calls token dot permit here is the one who pays the gas. So the owner never needed ether in their wallet for the approval steps. We have approval steps here in ERC-20, and in the state identical allowance is the set on chain. From here transfer from works exactly like normal approve. Now let's go beneath this, and then let's see when and what is EIP 120 26. Now you can see here the step 1, you the owner signs. You can see here the owner signs, and the message is not random string, it's EIP-712 type data permit, and owner spent owner spender value and owner's current nonce, and deadline nonce stop to replay, deadline stops, and old signature living forever. Now let's go over the signature. This is the second step, 3 pieces VRS, uh, VRS is handed to a spender, and this could be your front end or back end relay, or in our like test, just another address. And a very important thing you can see here is signature is not secret forever, in the sense that once you share it, anyone who sees it can submit the permit. That's why deadline and nonce matter, and third step here is to call permit, spenders call permit on the token, and with the same fields, owner signs plus VRS, spender pays the gas fees here. And now the next step is here the transfer form, which is after that the ERC-20 normal ERC-20 spends call like transfer form, and in transfer form function we along with this we send owner, a recipient and value, and tokens move. Owner never sent approved transaction. That's your full product story, permit gas approval. Now let's go below this. Yeah, we have permit. So in this slide, let's some context. When we write test, we don't open a MetaMask. Like if you see in my previous tutorials, we written in Foundry test. We don't open MetaMask. Foundry builds the same digest wallet. Would then sign it VM.sign, and then this diagram exactly what our sign permit helper does. So you can see here EIP. Oh, yeah, here EIP-2612 defines a fixed type string, the permit, and inside the permit we pass address of the owner, address of the spender, and the value, nonce and deadline, and we kekuk that string once, that's permit type hash, and then we ABI.encode the type hash with the actual owner, spender, and the nonce and deadline, and kekuk again, and the result is struct hash, the hash of specific permit. And if you want to deep dive, I would highly recommend you to go and watch read this EIP. I will give this link in the description. So let's go back and let's understand what is let's go ahead and let's understand what is EIP 2612. So flow, I shared the flow. I explained the flow. What is the inside like how things happens in EIP 122612. It may or may not be make sense initially, but when we write jump into the code, it will make sense. I will explain everything in detail. So in the one line, I would say the flow is very simple. Owner, there is owner and owner sign the type data, then it goes to relay, spender calls, and then permit function called, allowance is set, and transfer from works like normal, which which works in ERC-20. Now let's directly jump into the code and let's understand. So I have this one folder here, EIP-2612, and we are going to use Foundry as we use every time. So make sure you installed Foundry. I'm just going back. If you don't know how to install Foundry, you can go notice book.getfoundry.sh, and from there by running this command you can uh, install the Foundry. So you can see installation over here. Again here you can run this command, and I am copying this Foundry up. Let's go back and Foundry up. So you can see my Foundry is installed on my computer, and let's make first clear it. Let's start with by creating new Foundry project by running forge init. Then we don't need this, and let's install open Zeppelin forge install open Javelin slash open Javelin contracts. There we go. While it is installing, let's go. Let's delete this one as well. And yeah, and let's create a permit token contracts here. Permit token dot sol, and you can see our open Javelin contracts installed 5.6.1. Let's set remappings by running this command for remappings dot txt. So you can see here our remappings are set. Let's start writing the contracts. So let's start Pragma or the SPDX license identifier MIT and Pragma Solidity 0. Let's use 0.8.24, which is very stable. Oh, it's yeah. And let's start with contract permit token and let's import our ERC-20. Import ERC-20 from open Javelin contracts slash contracts slash token slash ERC-20 slash ERC-20 dot sol. Open Javelin slash contract slash token. Oh, it's not like this. Yeah, like this. It may import. Now let's import ERC-20 permit. ERC-20 permit from again open Javelin contracts slash token. Can you see here? Okay. Then ERC-20. Then we are using extension, right? Extension slash token ERC-20 extensions slash ERC-20 permit dot sol. There we go. Now let's make our contract ERC-20 as well. ERC-20 token permit or the permit ERC-20 permit, and there we go. Now let's set up our constructor over here, and inside the constructor let's take a string of name, memory name of, then we need to pass symbol, then we need to pass initial supply UNT256 initial supply, then address of the recipient recipient. Now let's go ahead and initialize our ERC-20, and inside that let's pass this name and symbol. There we go. And inside the permit, ERC-20 permit, we need to pass only the name as we described in the diagram. And now let's go below. What says wrong? Yeah, there is so much wrong. We have to copy this, and we actually forget to put it outside this. Now it's format, and now inside the constructor body let's add if initial supply is less greater than 0, then we need to run the mint function which is coming from ERC-20, and inside that we need to pass the recipient and the initial supply, right? There we go. And now what is the error? Yeah, you can see. So this is the very basic our ERC-20 smart contract, ERC-20 2612 smart contract, which is dev holders holders sign an EIP-712 type message off chain. Anyone can submit permit to set allowance without the owner sending the transaction. So in this video, let's compile, forge, build. So you can see these are some Foundry warnings, but our contract is successfully compiled successful with warnings. So in this part we are just we just build this smart contract. In the next part of this tutorial we are going to test this contract, and I will show you how you can test your contracts, and then we will deploy it on Ethereum circle. Yeah, so that's it. Thank you very much for watching. I am coming with a lot of advanced smart contract development and tutorials, so make sure you subscribe this channel for smart contracts, for learning smart contract development, and I will see you in the next one. Bye bye.